Hello, my name is Steve Bowler, and in this video we're going to be taking a look at access control lists. Specifically within access control lists, or otherwise known as ACLs, we're going to be taking a look at extended ACLs. And what we're going to find out here is that extended ACLs, unlike standard ACLs, extended ACLs will give us the ability to match on more criteria such as the destination IP address, our subnet, and also it's going to allow us to match different types of TCP and UDP traffic, layer 4 traffic. So what we're going to do here is we're going to take a look at a very simple lab here where we're going to have just two routers, router 1 and router 2. And what we're going to do is we're going to set up some extended ACL on router 2, and we're going to take a look at how to configure extended ACLs, how to verify that the extended ACLs are actually working properly via show commands. So give me 1 second here. I'm going to go ahead and pause the video. I'm going to set up the two routers with the baseline configuration, and then we'll take a look at extended ACLs. Okay, so now that we have both router 1 and 2 up here, let's go ahead and configure them. We'll get router 1. They're both connected to each other via their fast Ethernet 0.0 interface. So let's go into router 1 and get it configured. We'll do IP address 172.16.12.1/24. Again, this is going to be the network that connects router 1 to router 2. We'll go ahead and put the IPs in here for you guys to see. Also, what we'll do is we'll go ahead and create our loopback 0 interface on router 1. We'll give it all ones as the IP, and then we'll give it a /24 subnet mask. And then we'll go ahead and run a routing protocol in between here so we have reachability from the loopback interfaces between router 1 and router 2. We'll just do RIP version 2. And so that should be enough baseline configuration on router 1 to get us up and running here. Let's go to router 2 now and get it configured. First we'll do the fast Ethernet 0.0 interface between router 1 and router 2. And we're going to give it the 2 IP address and a /24 subnet mask. Let's go ahead and configure the loopbacks now. We have loopback 2, 22, and 10. So let's go ahead and configure loopback 2 here first. We'll give it all 2s as the IP address. And then we'll go ahead and do a loopback 22 interface. We'll give it all our 22, 22, 22, 22 as the IP address. We'll give it a /24 subnet mask. And then we will also do a loopback 10 interface here, and we will give it all 10s as the IP address with a /24 subnet mask. Next, we'll go ahead and configure RIP to run as the routing protocol between router 1 and 2. So we'll run that 172.16, the network that connects router 1 and 2 router 2 there. And we'll also do it on our loopbacks. So we'll do that with the 10 network, the 22 network, and the 2 network. Then we'll do no auto summary, so we are not summarizing at classful network boundaries. And then we will also put in here version 2, which allows us to send subnet information within our RIP updates. So now if I do a show IP route from router 2, you can see I am learning the RIP route from router 1 to the 1 network. And I have reachability. Let's go to router 1. Show IP route, and you can see I'm learning the 3 RIP routes, or the 3 loopbacks from router 2 now. Let's just go ahead and try to ping one of them. We'll just ping the 22 network, and as you can see here we have full reachability. So now we are able to go ahead and expand on our lab here, which is going to be on extended ACLs. What we're going to do is we're going to set up an ACL inbound on router 2 is fast Ethernet 00 interface. And what we're going to do is we're going to allow the source, which will be router 1's loopback 0 subnet, to reaching some of our destinations, which are our local loopback interfaces on router 2. So again, extended ACLs will allow us to match on more specific criteria, more so than standard ACLs, which we can only match on source IP addresses. Extended ACLs gives us the opportunity to match on layer 3 and 4 information. Layer 4 will be able to match on TCP, UDP information, and also we're going to be able to match on more layer 3 information, such as the destination network address, and also destination layer 4 information as well. So let's go ahead and set up an ACL here on router 2. We'll do this with the command IP access list, and we'll follow that up with a question mark. And as you can see here, the extended command is the first one here, and that is the version of access list that we're going to be using. So we'll go ahead and put access list there, extended, and then you can see here we have the extended IP range of numbers 100 through 199, and then 2000 through 2699. What we're going to do here is we're going to just use the word option, which allows us to create a named ACL. So we're going to create a named standard access list. I'm sorry, not a standard. We're going to create a named extended ACL, and we will call that in from R1. And now what we can see here is if we hit the question mark, we have the option to choose our sequence number, so we can add in, we can put different sequences, different statements in, different areas. So we can have, say we start with sequence number 10. Well, if we need to add something more specific that we match on before 10, we can go back and add a sequence number before 10, so 9876 or anything below that. So also we can see here we have the option to permit, to forward traffic, to deny traffic. We can do dynamic ACLs. Also, we have a lot more options here that we're not going to get into right now, which is pretty much out of the scope of this lab. What we're going to do here is we're going to match the source, which will be in this case loopback 0's network. So we'll do a permit, and as you can see here, it's going to allow us to do a lot of different options. We can choose the protocol number, or it has things already matched for us. So permit UDP, like we were talking about, TCP. We can do ICMP traffic here, so we can allow pings through. We can deny. So we can show you this. Let's do this here first on router 1. If I do a ping to 2.2.2.2, and we'll source it from 1.1.1.1. And as you can see here, this traffic is allowed through. But let's go through here. We'll create a ACL entry. We'll do sequence number of, actually we'll just do a deny, and we'll go back and see what the default sequence number is here. So we'll do a deny ICMP, and as you can see here, we have options for a source IP address, any source, or host, where we can match a single IP. So in this example, let's just use the host option. So we'll do deny ICMP host, and then it's going to ask us for the host name or IP address. In this case, we will use the loopback 0 interface on router 1, which is 1.1.1.1. And then as you can see here, it's going to ask us for the destination. So again, this is one of the advantages to extended ACLs, is it gives us the option, or we're going to have to match a destination. It can be either a specific address or any, right? We can put in here with the destination address, we can put in like a subnet, a network of IPs, or we can choose the any option, or we can again specify a single host. So in this case, I'm going to show you how to use a network range here. So we'll do, like before here, we were able to ping the 2 network, our loopback 2 off of router 2. So let's go ahead here and do 2.2.2.0. Now it's going to ask us for the wildcard bit. So we'll do 0.0.0.255, and basically this is just a /24 in a wildcard format. Then, if we hit the question mark, as you can see here, we have a lot more options that we can choose with extended ACLs. And when I mean a lot, I mean, as you can see here, a ridiculous amount. But what we're going to do, we're not really going to worry about these right now. These are all out of our scope of this lab. We will just do a simple deny ICMP host 1.1.1.1, and this is going to be going to the destination of 2.2.2.0 0.0.0.255, which is basically the /24. This is the network off of loopback 2. So we'll go ahead and do that and hit enter, and then we will just do a permit. At the end here, we will do a permit IP from any source to any destination. And we'll leave it at that for now with our basic extended ACL. And if I do a show IP access list here, you can see we have 2 statements, the 10 and the 20. And as we can see here, the default, it's going to give us sequence number 10. So with this ACL set up here, now what we need to do, just like standard ACLs, we have to apply this ACL to an interface. So what we're going to do is we're going to go into interface fast Ethernet 00, and we're going to do the command IP access group. Then it's going to ask us for either the number of the ACL, standard or extended, or it's going to ask us for the name. So here we're going to put the name is going to be in from R1. Because again, if we go back up here to the top, that's what we chose for the name of our extended ACL. So with this set up, now it's going to ask us, okay, how are we going to filter, inbound or outbound? And what we're going to do here is we're going to be filtering inbound. Hence the name of the ACL in from R1. So we'll just go ahead and hit enter. I'm sorry, we'll go ahead and hit in, and then, or we'll type in and then hit enter. And now you can see we have successfully applied this ACL to our fast Ethernet 00 interface on router 2. So now if I go ahead and try to do this ping again, what we should see is now we are getting undeliverables, or unreachables. So if I go back to R2 and do a show IP access lists, what we can see now is that we have matches that are being hit up for our deny ICMP statement within our extended ACL. And again, these matches are these pings that we were doing on R1. What we were telling R2 to do is deny this ping, or this ICMP traffic, from this host of 1.1.1.1 to any host any destination on the network 2.2.2.0/24, and then to permit all other traffic. And the reason you're seeing this permit IP any, now this traffic here could be RIP traffic, could be a lot of stuff. Let's go back into our extended ACL and take a look. Let's do a sequence number of 15, right? So we'll do 15. We will do a permit UDP from any to any, and then we will put in here the command match only packets on a given port number. So what we can do here is we can put a range of ports to match on. We can use the time range command here to specify a time-based access control list. We can do greater than port, less than. As you can see here, there's just so much information to get overloaded on. What we're going to do here is we're going to create a sequence number 15. We're going to permit UDP any, and then equal to, and then it's going to give us a list of well-known ports, UDP port numbers. And again, if you remember, we're running RIP between router 1 and 2. So what we can do is, and what I can show you here is by adding the sequence number 15, we're going to see this RIP traffic being allowed through. So if we do 15 permit UDP any from any source to any destination equal to, and then we specify here RIP, we'll go ahead and hit enter here. And now if I do a show IP access lists, now what we can see here is that we have some matches on this RIP traffic. So it's very important whenever you're dealing with ACLs, you have to remember what kind of traffic you have running on that interface. Whenever you apply an ACL to an interface, you have to think, okay, is this ACL going to break my routing domain? Is it going to break any other type of traffic that I have going across here, layer 4 traffic, TCP UDP traffic? So you have to be very careful, because if we were just to say have one permit statement in this ACL and then have just an implicit deny, well, if that permit statement wasn't permitting our UDP traffic, our RIP traffic, then we would break our routing. And I'll show you that here too. So again, as you can see here with the show IP access list, to verify this, we added a sequence number 15 permitting, again, RIP runs on UDP, and we did a permit UDP any equal to RIP traffic. And as you can see here, we're getting 9 matches. So we're seeing that RIP traffic being permitted through this ACL now. And now again, if I do a show IP route on router 1, you can see I'm learning these 3 RIP routes from router 2. Well, let's do this. Let's go ahead and try to break this routing by going into the ACL, and we'll do a sequence number 14, and we'll do a deny statement. So we'll deny UDP from any to any equal to RIP. So now if I do a show IP access lists, you can see that we have our sequence number 14 that we just added to deny UDP traffic from any source to any destination equal to RIP. And now you can see that I'm seeing 3 matches for this deny traffic. So now this RIP traffic is being denied. So what we should see here, if I do a show IP protocol on router 2, I'm still seeing a gateway. I'm still seeing router 1. However, looks like our update, if we do another show IP protocol, what we will see here in a 3-minute time period, our hold down time, once it expires, we should see these networks being down and then being flushed out of our routing table after 4 minutes. So let's go back to router 1. Now if I do a show IP route on router 1, you can see here that we still see this traffic, we still see the rip routes in our database. And if I just go ahead and try to ping 2.2.2.2, now doing this ping, we are using this exit interface on router 1 as the source. So that's 172.16.12.0. I'm sorry, 12.1. If I do a show IP access list on router 2, we can see here that we do not have any ACL entry that is denying this source traffic from reaching any destination. So we should be able to ping from the source, which is going to be 172.16.12.1 to destination 2.2.2.2. And as you can see here, we are successful. However, if I do a show IP route, actually let's do this. Do a show IP protocols. What you can see here now is that the timer is incrementing up to 2.5 minutes on router 2. Once this reaches 3 minutes, then we're going to be in trouble. So now if I do a show IP route on router 2, we can see here that it's showing the loopback of router 1 is being possibly down. However, on router 1, you can see here that I do not see that information. I'm still seeing updates coming from router 2. And I can still ping the rip routes. However, router 2, if I go ahead and try to ping from router 2 to router 1, looks like we are still successful. Let's do this. Let's do a show IP route now, and now you can see here it looks like that route's been flushed out of our routing table. So I go ahead and try to ping it now on router 2. You can see here that we have broken our RIP domain. However, on router 1 we can still ping the networks off of router 2. And that is because we are still seeing the updates coming in from R2 to R1. And that is because this ACL is applied inbound to router 2's interface and not outbound. So what that means is that all this RIP traffic inbound to router 2 is being filtered. And that's why router 2 cannot see router 1's loopback. However, router 1 can still see router 2's RIP routes because there's no filtering outbound. There's no filtering outbound on router 2 taking place with RIP, so these updates are allowed out to router 1, and there's no filtering inbound on router 1 to filter these networks. And that's why if we do a show IP route, we're seeing updates being sent out, and if we do a show IP protocols, we're still seeing, updates at a fairly low time range. So, however, you can see the effects of the deny statement in our ACL. Okay, so let's undo this problem that we induced into our lab. Let's go ahead and take this 14 sequence number out, which was to deny our RIP traffic. So we understand the potential problems we can face if we apply ACLs to an interface and we are unaware of all of the traffic that is traversing that said interface. If we have an implicit deny at the end, then we're going to be blocking a lot of traffic that we might not want to block. So there's tools that you can use to find out what kind of traffic's running over the interface, like the QoS tool of NBAR, network-based access recognition or application recognition. So we can use NBAR, we can apply that to an interface, and it'll tell us what kind of traffic and the protocols that is running over that interface. So let's go ahead and back into this ACL, and we will go under the 14 statement, and we will do a no 14 deny UDP any RIP. So if I do a show IP route now on router 2, now you can see here we are learning the RIP route again. That was pretty fast convergence for RIP, I have to say. Anyway, now we're seeing the RIP route from router 1. We can go ahead and try to ping that, and we are successful. So again, extended ACLs, a very good tool that you can use to not only match source like standard ACL, but we can use them to match our destination IP range, also a host, or we can match all destination traffic. We can also match different types of protocols, like routing protocols as we've seen here. You can also match on other TCP well-known ports as well. You can also match ICMP traffic like we did here if we do a show access list. Oops, here. Let's go ahead and do this now. Let's go ahead and do an ACL inbound on router 1. And this ACL on router 1, we will call it an extended ACL again, and we'll do in from R2. And then here we're going to allow TCP traffic. We'll just do permit TCP, and the source we will do from host 10.10.10.10, and we will apply this to host 1.1.1.1, and then we're going to use the equal command again here, and we will do equal to, and we will do web traffic, so www. Well, you can see here too at the end we can also do a log statement, a log input. This will allow us to match more specific information. This command is going to allow us to, like it says here, include the input interface and the source MAC address. Let's go ahead and do that command there, log input. And we'll also do a permit IP, all IP traffic from any to any. So what I want to show you here is how we're going to match this web traffic here. If we do a show access list here on router 1, you can see I have two sequence numbers, 10 and 20. One is going to be permitting TCP traffic from the source of 10.10.10.10 to destination. Destination is going to be 1.1.1.1, and this traffic is going to be equal to web traffic, and we'll be logging the input, which means the inbound interface and the MAC address information. So let's go ahead and try to replicate this type of match here in our ACL. Actually, let's do this before. Almost forgot, we got to go under the interface, fast Ethernet 00 on router 1, and do a IP access group, and then in from R2, and then we will specify here in. So we want this is going to be inbound again from R2. So you can see here we have inbound or outbound packets. We'll do in. Okay, so now we're going to try to simulate this traffic on router 2. We'll do a telnet, and then we'll telnet to one dot one dot one dot one, which is going to be our destination, and we will do this. It's going to give us a bunch of information here that we can use when we will do this telnet via TCP port 80. So we'll do www. Then we'll also do the command source interface, and then we'll source this from loopback 10. And as you can see here now, we are hitting this ACL. As you can see here with this log information that we're getting here, it's giving us the access list name in from R2, and it's going to say here permitted TCP traffic from our, like we were said here in our ACL, our extended ACL on router 1, from our source, which is 10.10.10.10, to the destination, which is 1.1.1.1, via web traffic port 80. And again, the log input feature, our extension on our end of our extended ACL here, is going to again give us the interface and also the MAC address. So if we do a show access list here, now we can see that we have 3 matches with our sequence 10 permit statement. So this is a very cool features that we have here with extended ACLs. As you can see, whatever you can think of pretty much in an ACL, you can implement with an extended ACL. And as we've seen here, we created 2 extended ACLs, one on router 1, one on router 2, and we went through some of the tools and showed you some of the very important features of extended ACLs. The first feature, or the first access list on router 2, we showed you how we could deny ping traffic or ICMP traffic from a host on router 1 from reaching the destination network on router 2, the loopback 2 network. We also showed you about a very important feature that the RIP traffic was being permitted with our permit IP any, and we saw this by breaking the network by creating a deny statement. We created the 14 sequence number, the deny UDP any equal to RIP, in which we actually saw RIP packets were being denied inbound from R1 to R2, and what that did was that broke the RIP domain in which R2 no longer had reachability to R1's loopback interface, which it was learning via RIP. So we also explained some of the key features in ACLs as to if you don't know what kind of traffic is running over your network, you have to make sure you find out what kind of traffic you have running across there, because if you put an ACL on there that has an implicit deny any at the end, you could break your network and not know about it. So it's very important that you know what kind of traffic you are running across your network, and specifically across your interfaces, before you apply an ACL on it. And then the last thing we did here is we went on to router 1. We created an extended ACL inbound, in which I showed you how you can simulate different types of traffic. In this case, we simulated web traffic from R2's loopback 10 interface coming inbound to R1 and hitting the destination host of 1.1.1.1, and we also showed you the importance of the log input extension at the end of the extended ACL. So I hope you guys have enjoyed this video, and I hope you'll be with me with the next one. Thanks.